AP Calculus AB, Unit 9, Day 2. There's a warm-up. Practice some of there's 3 problems, 1, 2, and 3 problems. So go ahead and try and practice this. This is like problems from the previous assignment. Write Riemann sum using all the values in the table for 1 and 2, trapezoidal. And then number 3 and 4, using whatever values from this table that makes sense with the number of subdivisions and the approach. So pause the video, try these out yourself, see if you're getting the hang of it on your own. Okay, next, so this one, these are not equal subdivisions, which is pretty common on AP test. I personally would draw a picture and say, okay, well, it's going to be 1, 5, 7, 10. Now, I don't try and make these super accurate or anything like that. A lot of times I'll draw the heights relatively kind of correct. So right Riemann sum, right endpoint Riemann sum means we're using the right side for the heights of a rectangle. So we're not going to use that guy. And these are the bases of our rectangle. So Riemann sums are always rectangles. So the integral from 1 to 10 of f of x dx is approximately 4 times 3 base times height, 2 times 2 base times height, 3 times 10 base times height. So that's going to be 12 plus 4 plus 30 is 46. So the approximation for the integral of f of x from 1 to 10 is about 46. Okay, next one, trapezoid. So it's the same picture. Yeah. Same value, same slices, but this time I'm going to connect them with secant lines, which create trapezoids. And the values down here at the bottom, instead of being bases, they're actually the height of the trapezoid, because the trapezoids are sideways, kind of sideways from the way we usually sort of picture them. So trapezoids, you gotta show the work. We're approximating the same integral, but remember they're just rectangles. Base times height, the average of the bases, 8 plus 3 over 2, average of the bases times the height. Average of the bases, 3 plus 2 over 2 times the height. Average of the bases, 2 plus 10 over 2 times the height. Okay, so that's your setup, and so that's going to be 2, so that's going to be 11, that's going to be 22, it's 5, it's going to be 6, times 3 is 18, so it's going to be 20, 30, 40, 45. Is the approximation. Close to the last one. Okay, next one's we're using this table and using the number of subdivisions equal width that they tell us. So this is 3. So I mean, we could start by drawing a quick picture. 1 to 13. If it's 3 equal subdivisions, it's going to be this divided by 3 is 4. So they're each going to be 4, right? So it's going to be 5, 9. Look the values up. This is 8. 5 is 9. 9 is 12. And 13 is 2. And we're doing left endpoint Riemann sums. So we're not going to use that guy. So the estimate, 1 to 13 of f of x dx is approximately base times height, 4 times 8. Base times height, 4 times 9. Base times height, 4 times 12. So it's going to be 32, 36, 48. So that's going to be 80, 116. Is the approximation. And it really makes sense to use this symbol in this scenario. Okay, midpoint Riemann sum. So we're looking at 1, 5, 9, 13, just like last time, except we got to split the difference. And it's going to be 3, 7, and 11 that we got to look up these values. So in the table, 3 is 2, 7 is 20, and 11 is 8. And those are going to be the heights of our 3 rectangles. Okay? So 1 to 13 f of x dx is approximately, the bases are still 4, height's 2. Base times height, 4 times 20. Base times height, 4 times 8. So we're going to get 8 plus 80 plus 32 is 120. So that's just some good practice for what we've been doing in Unit 1. Today, we're going to talk about definite integrals again, a little more detail. We've done this before. So for now, what is it? What are we trying to do? We're trying to find this function right here. Square root function is like the top half of a sideways parabola. And 4 to 9 means we're trying to find sort of like the area from 4 to 9. Okay. Now, so is it area? Yes. The integral would be equal to that area. But what if we did negative square root of x, which would be the bottom half of a sideways parabola, and we did 4 to 6 or 4 to 9. We found that. We'd get the same value, except this one would come out negative. And area is technically never negative. So yes and no. So that's why we actually like to call it signed area, because it could come out negative. If it's below the x-axis, it's going to come out negative. Okay. So let's go ahead and show the work up here real quick. So the work, we've been doing these definite integrals since last unit. I'd rewrite as a rational exponent because it's power rule. Bump it up 1, divide by the new exponent, plus c. And then we're going to go 4 to 9. Now, we don't really need the c. I'm going to show you why we don't need the c. So if we plug 2 in here, 9 to the 3 halves, so you plug the top limit in first, and then you plug in the bottom limit in second, and you subtract it, the whole thing. Now, if you distribute this, the c's are going to cancel each other out. And that's always going to happen. So what we just say is we just allow ourselves to be lazy and not write the plus c in the first place. It's there. Technically, it's there. It's just always going to go away. All right. Square root of 9 is 3 to the third power. Square root of 4 is 2 to the third power. So this is going to be 18 minus 8 16/3. So if we want to give them least common denominator, 54 minus 16, which would be 38 over 3, which would be 12 2/3. So that's our answer. So over here, in both of these problems, the area is 12 2/3. Both ways, the area can be negative, right? No such thing as negative area. Okay, area can be negative. But in this case, we associate with the area, and if you were to integrate this is just like the one we just did. The antiderivative would be negative 2/3 x to the 3 halves. You get the same antiderivative with it, just a little negative in front. And then if you were to plug the values in, you get negative 12 2/3. So you will get a negative answer if you just work it out by hand. Okay, but that's why we call it signed area. Now, another way that you could get a negative is if you flip the limits, right? So even if the function is above the x-axis, you could get a negative answer if the limits are backwards, because it's like you're going right to left instead of left to right. So that could give you a negative answer also. All right, let's talk about something new. And it's challenging, and it's going to come up a bit in some other lessons coming up soon. How do we integrate absolute values? Now, generally, how do we deal with absolute values? Could we just drop the absolute values and just integrate it? Let's see what we get real quick. 2x squared over 2 minus 6x. Don't need the plus c. It's a definite integral. 0 to 4. Plug 4 in. We get 16 minus 24. Plug 0 in and get 0 minus 0. The answer comes out to negative 8. Is that cool? This is for sure wrong this time, because you guys know that absolute value graphs are going to everything's going to be positive, right? So there's no way you could get a negative answer if you're going left to right like normal. So that's clearly wrong. We can't just ignore them, which hopefully. Now, there's a couple different ways we could do it. We could use geometry in certain problems, okay? So if we were to integrate this, we could graph it. We could say, okay, well, it's a line. It has a y-intercept of negative 6. I'm going to start without the absolute values. Okay, so, and it has a slope of 2, up 2 over 1, 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 up 2 over 1. So that's without the absolute values. Then the absolute value, what it does, you guys should remember this, it flips the negative part up. So now it's going to go through positive 6. So this is what the actual graph looks like. Okay? And this could be a strategy to find the answer. Now we're going to go 0 to 4. So we're going to try and find this area and that area right there. And by the way, this is the same problem we just did. So our strategy, remember the original line, by the way, was y equals 2x minus 6. Our strategy could be like, let's just make it a big triangle plus a small triangle. So we could just do 1/2 base times height plus 1/2 base times height. We could just find the two triangles, add them together. And that's fine. The base of the first one is 3, the height is 6. The base of the next one is 1, the height is 2, based off the slope of up 2 over 1, right? And so we get 9 plus 1 is 10. 9 plus 1 is 10. So that is the right answer, and that is an option that you could use on your next test. On the homework tonight, they might tell you to use geometry. That's what it means. Now, this only works for very linear types of functions where you're going to get rectangles and triangles and things like that. So what if it's not linear? Like how are we going to pull that off? Like this function right here, this is a parabola. If you did a quick, it goes through 0 and it goes through 2 is another y-intercept. And so it's a parabola. I'm just going to draw a rough parabola, but at least going through the right x-intercepts, because that's a big deal on these problems. Okay, so it's a parabola. The absolute value flips that like that. So this is the final answer. The negative part gets flipped up. And we're trying to find the area from 0 to 6. So 3, 4, 5, 6. So we're trying to find this area and this area. So how do we pull that off? We can't use geometry, right? So here's our strategy. We know how to find this area. Just integrate 2 to 6 without the absolute values. We know how to find this area, 0 to 2, but it's going to come out negative, and we want it to be positive. So we're going to fix this area and make it positive. And this area is already positive, so there's nothing to fix there. And so the way, a lot of times what we do to deal with absolute values is we break it up into positive cases and negative cases. So we want to figure out where is it going to be negative without a graph. Okay, so let's approach this as if we didn't have a graph. You'd want to find the zeros, set equals 0, find the x-intercepts, right? And then you could do a quick line check. You say, all right, let's put these on here. Let's test a value. X equals 3. It's going to be positive, negative, positive. So you go, oh, here it's negative. Now this gives you a couple ideas. It tells you where to split it up. So we have to split it up at 0 and 2. Okay. So we're going to use a line check to figure out where to split it up and where it's positive, negative. And so then we rewrite this. We say, okay, well, from 0 to 2, 0 to 6, we got to do 0 to 2 on its own, drop the absolute values, and then you're going to force it to become positive by putting a negative in front. That should do the deal, right? Plus 2 to 6, x squared minus 2x without absolute values anymore. And that one we just leave the way it is because it's going to come out positive. But this is how we do it. So now we need to integrate this. It's going to be x cubed over 3 minus 2x squared over 2 from 0 to 2. Now here's the deal. This guy is going to have the same antiderivative. It's going to be x cubed over 3 minus x squared. So don't think too hard about that, okay? It's like you're doing the problem twice. So then we need to plug 2 in. It's going to be 8/3 minus 4 minus 0 minus 0, because remember, we've got to plug in the bottom limit next. And this one, plug 6 in. 6 times 6 is 36 times another 2 is 72 minus 36 minus 8/3 minus 4. So there we go. Now we just got to try and clean this up. So, I mean, we could say, okay, least common denominator. It's going to be negative 12. It's going to be positive 4/3. Now, by the way, this whole chunk better come out positive. Otherwise, you messed up. Because you should have added a negative to fix it. All right, so the fix is with the extra negative in front. So that's the area of that little chunk right there. And then this other one, 36. You can add a 4, so it's going to be 40. You do least common denominator, 120 minus that, it's going to be 112. And that one should come out positive on its own. Otherwise, you did something wrong. And then together, you're going to get 116 over 3, or 38 would give you 114 and 2/3. So that's that total area. The area right there was 4/3. It was negative. We fix it with an extra negative. The area here is 112/3. And so we get a total answer of 38/3. So that's how we do it. That's how we're going to do integrals of absolute values. If it's linear and they tell you use geometry, draw a picture and just use geometry. But most of the time, it's not going to be that easy. And this is approach state. Now, this approach would have worked on the earlier absolute value one with the line also. Now, here's something you can do. You could check your answer on your calculator real quick. I mean, yeah, there's odds. You can check them in the back of the book. But you could also put these in your calculator. So like this last problem right here, we could have done math 9. This is what my calculator looks like. I'll talk about what some of you guys have better, newer calculators than I do, and that make more sense to use. But now we got to put absolute value in it. Math, num, ABS. So we've used this before. And then x squared minus 2x, close parentheses, comma x, comma 0, comma 6. And this should do it. Let's see what we get. We should get 38.6666. There it is. Cool. We got it right. So some of you guys, your calculator looks like mine, and you got to do math 9. Okay. And so you got to put math int, math int. You got to put the function abs x squared minus 2x. You got to put the function that you're trying to integrate. and then comma x, what you're integrating with respect to, that's the dx. That's the dx part. Comma, lower limit 0, upper limit 6. So lower limit, upper limit. And it gave us 38.666666964. It's not perfect. This is not an exact answer because it's actually using slicing techniques to estimate it. Now, some of you guys have a newer one that actually gives you something that looks like an integral, which should be a lot more obvious what to do. So this is where you put your function at. This is where that goes. This is where the dx goes. And then the lower limit and the upper limit. And then you should get the same answer. So try today's assignment. This is just encouraging you to start working on a corrective for the retest, but this is your assignment for today. Check your odds in the back of your book. They're almost all odds. I think there's one even problem in the whole assignment. Also check your answers on your graphing calculator. Plus, it's going to get good. It's going to be good to get really good and quick at doing this on your calculator, because if you do have a calculator allowed on the AP exam, it's way better. So try the assignment. Check your odds.